Today we will represent our X582's final project. The topic is Deterministic Record and Replay Debugging of GPU Programs, advised by Tanvir. First, let's talk about what is the programs. In massive parallel GPU programs, it suffers from concurrency bugs. Record and replay is a debugging technique, but it is hard to be adopted to GPU programs due to two reasons. The first is there is a lot of non-determinisms due to the interleaving of threads and the complexity of heterogeneous computing model lead to different results for record and replay. So in our project, we need to determine the source of non-determinisms, and then based on our finding, we have to develop a tool that can make deterministic record and replay for CUDA programs.
One of the closest related work to our project is called PinPlay, which is a framework that captures the program execution and later deterministically replay it with reasonable runtime and usage on disk on CPU. And the framework relies on a dynamic instrumentation tool on CPU. But in our project, we are doing something very different because, as we all know, GPU architecture is very different from CPU architecture, and as a result, we cannot use the existing tool using PinPlay to record and replay programs on GPU. And so we are using another tool called NVBit, which is a dynamic binary instrumentation framework for NVIDIA GPUs, which supports all recent NVIDIA GPU architecture families.
So talking about our progress, so far we have accomplished the record and the thread instruction, which is the load and store instruction order of GPU programs. In that, we assume that the non-determinism only caused by load or store instructions. And for the simple detection of write or write-read data races, we have implemented some simple logics to determine it. And finally, we have finished the replay part by replaying the programs using reading and replacing register values in the load and the store instructions. So the next thing to do is we want to optimize the record and replay by reducing the amount of instrumentations. We only now record the load and store orders, but now we think we can make some more improvement to reduce this amount of instructions. So talking about evaluations, we measure our project in two metrics. The first thing is effectiveness. We can test our programs on benchmarks such as Rodina 3.1 and NVIDIA's CUP SDK samples that already contain non-deterministic bugs. We want to find out whether our programs can find those bugs. And another thing is efficiency. We want to measure the overhead of record and replay parts of our programs. And then we can compare it with tools in CPU recording and replaying programs, something like PinPlay. And finally, for the challenges we have already faced, the first thing is for the replay part. In order to fix the thread implementation orders, we implement logs in GPU programs. But as you all know, GPU has a lot of concurrency, so using logs in GPU programs will cause the overhead of record and replay very large. And also, the problem is too much information is recorded concurrently. That will also introduce a lot of overhead. It is expected only recording instructions that may cause non-determinisms. And also, the PinPlay is maintained by the Intels, but for the NVBit, we can only use the user-level API. The source code is not open sourced, so we need to do some experiment to find out what is the logics of the NVBits. So this is all the challenge we have faced. Thank you.